What's up, guys? Let's take a look at another Code Wars exercise. This one's called Fun with Lists, countIf. And if you scroll down, you'll see there's a series with these lists, and I might look at some other ones. They're all pretty good. But the countIf is a function that looks through a list and counts how many meet some criterion. You give it a function which has a Boolean result, and that's called a predicate because it's like whether or not it gets into the body of the answer. And that's easy enough. However, this is a different kind of list than we've seen before. This is what they call a linked list, where each item points to the next one, and that points to the next one, all the way down the line. And linked lists are involved in a lot of coding challenges for, I would say, two reasons. One is that they do match the kind of thing you might have to do in memory if you're ever dealing with raw memory addresses. You might have an array of bytes next to each other where they can just go to the next byte and they're contiguous, but you might also have things all over the place that need to point to each other in order to find the next one. That's not something we deal with in Python, but the other way to use this idea is with any kind of graph or any kind of idea that involves one thing pointing to its connections. For example, if you're doing like a Google Maps direction kind of thing and you go, okay, well this road could lead to this one or this one, then it'll have little references to those other guys, and you have to sort of travel down the graph figuring out your best route. Now, I'm going to show my way of writing this, which is definitely not the only way, and when we look at the solutions, we'll see a couple different versions. So basically, what I want to do is this. I want to be able to say the sum of, and then they've got, the name of this function is just func because we don't know anything about it. It's very generic. It could be checking if a number's even, or it could be checking if a person is over 18, or it could be all kinds of criteria. And then I'm going to say node because node is the name of one of these items in a linked list. For node in, now we don't know what the name of our thing is, right? Because this function, it takes the head of the list, meaning like the first one, and then that points to the second one, and that points to the third one. So we have to have a way to traverse down the line, and we don't. It's not like a Python list where the list itself holds many references to every item. It's one to the next, one to the next, one to the next. So we have to build a little structure that's going to find them. And so I'm going to make a separate little guy up here, and this is going to be, I'm just going to call it linked because this is a linked list, and it'll take a node, probably the first node of the list, but we might start in the middle and go down the line, who knows. And then basically we're going to say a new keyword that I haven't showed you guys yet. Whenever we're doing a function, we can say return, right? We can say return node, and then it'll kick out of the function, we're done, here you go. But there's another way to hand an answer to your caller, and that's something called yield. Okay? Yield is a great tool that we're going to see sometimes, which hands you one thing and says, come back when you want the next one. So instead of a function, this is called a generator, which will just pause. We'll just say, like, here's the next node, and then when you come back to me later, I'll have the one after that. And when you come back to me later, I'll have the one after that until I run out. So I'm going to say node equals node dot next because I need to say, I just gave you that one. Now I'm going to get the next one prepared so that when you show up the next time, it's sort of like popping items off of a stack. So they tell us that the node object, which we're dealing with here, has two attributes. There's next, which will be another node pointing to down the line. And then there's data, which could be not another node, but it might be a number or a string or whatever. So I'm going to say node is node.next, and then we need to loop until we run out. So I'm going to say while node, we do that stuff. And this is a classic generator in Python. It'll give you one node, and then when you come back, it'll give you the next one. And when you come back, it'll give you the next one. This is actually very similar to the range function in Python when we say, for I in range 5, it gives you a 0, and then when you get back again at the top of the loop, it gives you a 1. And when you come back again at the top of the loop, it gives you a 2. And it will exhaust those items until it's out, and then the loop moves on. So now we can loop through this and say linked node and do what we wanted to do all along after this generator organizes the list. So if I hit test, it's probably going to get it unless I made a mistake. And hey, guess what? I did make a mistake because when we look at these nodes, we're not doing... Oh, I actually made 2 mistakes, I see now. We're not doing the node itself. We're cracking it open to see the data inside. It's like a conveyor belt with boxes. We have to open up the box. So I'm going to say node.data to peel off the container and look at what's inside. But I also made another mistake. I see the error message is actually telling me something else. It was saying this thing is not the node, it's the head, because this function gets the head of the list, which is where we're starting. Okay, we don't actually know if it's the first one. There could be ones before we got here, but we know that we're starting here and we're looking in that direction. There is another concept of a doubly linked list where everybody points backwards in addition to forwards, but we are not working with that now. We're just saying each node knows what it has and it knows where the next guy is, and those are the only things in the world if you ask the node. So now if I try to test it, hey, we got it, and if I hit attempt, we're probably going to get all those as well, because this is not testing huge amounts or crazy tricky edge cases or anything. It's just seeing if we can set it up. Now let's check the solutions from other people to see how they did it. This person has a counter, a while loop. We look inside, go to the next, bada bing, bada boom. This is a little bit better than mine if we only had this problem, but I'm kind of imagining what if we had to go through the list. For other reasons, it would be nice to use the linked generator in a versatile way that could use other approaches. Same thing here, we have a while loop, and then we try the thing, add up to our counter. I don't like the I. When I see counter, it makes sense of like, oh yeah, we're counting how many, which may be 1 for every step, or it may be none ever. We might find that none of them qualify by the predicate. Whereas I is a little misleading, because whenever we see the name I, we assume we're counting 1 for every step, like an index in a list, This one uses a very nice expression. Even though it has a lot of steps, they're each very small and they make a lot of sense. So we say, try this current head of the data or nothing for this one step, and then for the rest we send it back through the same function recursively. So this is really great. It's kind of how you would do it in purely functional languages like Haskell or something like that. I think this came originally from a language called Lisp. I think the idea comes from Lisp, where that whole language is about dealing with lists, as you could probably guess from the name. And they always say, we've got the 1 in the front and the rest. And then we take the 1 of that and the rest. And then 1 of that plus the rest. Same thing here. A lot of these guys are using a variable to count, and I was just using sum. They're all using a while loop except for the recursive one. And so even though these solutions look a bit different, they are generally doing the same thing. And so I would recommend, if you like this one, to check out the other katas in the series, especially if you set up this generator. You can use that in every other one, and boom, solve them in a single line. Boom, check everything out in a single step, because this generator goes through the list, handles it all, ends when it ends, handles any problems. Great. There you go.